Hello everyone. Today I will show the solutions to problems 5 and 6 of round 164 of the Prairie Math League. For problem number 5, we wish to find the average of all 5-digit numbers that can be formed by using the digits 1, 3, 5, 7, and 8, each exactly once. So a valid example would be something like 37,185. And we wish to find the average of all such numbers. First, we just note that we're trying to find the average of a bunch of digits, so we can it might be helpful at the beginning to just find the average of all the digits, and that's 4.8. Now, we now use a very powerful tool known as linearity of expectation, which basically states that the sum of an average is equal to the average of the sum. So to see what this means, we first break this number up into its base 10 meaning. So 3 times 10 to the power 4 plus 7 times 10 to the 3 plus 1 times 10 squared plus 8 times 10 to the 1 plus 5 times 10 to the 0. Now, we wish to take the average of all of these numbers taking the form where these are the aforementioned digits, each of which is used exactly once. But here we can split each, using linearity of expectation, we can split this into taking the average of every single term. So, for instance, we can take the average of all some digit times 10 to the power 4, and then add this to like the average of all some digit times 10 to the power 3, all digits times some digit times 10 to the power 2, and so on. And this is quite powerful because if we just take a look at a single digit, let's say some digit n times 10 to the power 4, well, the average of all such numbers with this form, with using only these digits, is basically equal to this average that we got, 4.8 times 10 to the power 4, because 4.8 is the average of all the digits. So now we can use the linear expectation results to get that this gets 4.8 times 10 to the 4 plus 4.8 times 10 to the 3. We're just using the same strategy here, and times 10 to the 3, and so on. And we can continue pretty much in this way, abusing exactly the same argument. And this gets us 53,332.8, which is option choice C. Alternatively, right here, you can just look at this. And if you don't want to do the rigorous proof, you can just skip directly to multiplying this by 1, because we're just basically kind of doing this same argument without actually doing the proving the argument itself, and we get basically the same number. Now, for problem number 6, we have x and y, which are two-digit integers, such that y is obtained by reversing the digits of x. These integers satisfy x squared minus y squared equals m squared for some positive integer m, and we wish to find x plus y plus m. And I'm pretty sure x and y are positive integers, but let's ignore that. Yeah, we assume that x and y are positive. So first we let x equals 10a plus b and y equals 10b plus a. And we do this because we're basically taking the form of x and y, which are basically two digits, such that like for x we have this, and for y these digits are like reversed, like, yeah. So now we take this form and basically put this in like a base 10 representation to get x equals 10a plus b and y equals 10b plus a, where a and b are digits. Now, we're going to get something right like out of the way right now. These have to be non-zero. Otherwise, we're going to get numbers that look like 30 and 03, and this is obviously not a two-digit number. So we have these are non-zero digits. And furthermore, from here, since m is a real number, since m squared is a positive number, we must have that x is greater than y. Therefore, 10a plus b greater than 10b plus a, and we can easily show from there that a is greater than b. Thus, we have b less than a, less than or equal to 9 because these are digits, and 1 greater than or equal to b because they're positive digits. Now we have these bounds out of the way, and we're actually going to take these forms and finally substitute it into this equation that we haven't used yet. And we get m squared equals x squared plus minus y squared. Substitute, expand, cancel out a bunch of terms, and then we can factor this. We can use the difference of squares expansion to get a plus b, a minus b. But we're also going to prime factorize 99 to get 3 squared times 11. Now, right away, we can see something here. If we have a square, we have something of the form p1 to the power of, like, r and 2r1, p2 to the power of 2r2, times etc. So any square must take this form. And in particular, these exponents must be even. So somewhere here, we have to have another 11, or at least another factor of 11 to match up this 11 to the power of 1, in which case it's odd and it won't work. So yeah, basically one of these has to be divisible by 11. Now, we can write this as 11, either 11 divides a plus b, or 11 divides a minus b, or both. But notice right here that 11 cannot divide a minus b. This is because, as we saw in here, these are bounded by 9 minus 1, which is less than or equal to 8, and 8 is the largest 8 is smaller than the smallest 11, which is kind of sad, but whatever. It means we can completely eliminate a minus b, and we're just left with 11 divides a plus b. Now, we notice that a plus b is at most 17, and the largest 17 is smaller than the smallest 22. So again, we can't go this direction. Therefore, a plus b, because it's 11 divides a plus b, we thus must have a plus b equals 11, because this is the only factor of 11 that the only multiple of 11 that it can possibly be. So we have this now, and we can now the problem is pretty straightforward from there, because all we need to do is like try a few possible values of a and b. We can test 9 and 2, 8 and 3, 7 and 4, 6 and 5. I mean, these all satisfy these conditions that we've just got here, but these also satisfy a plus b equals 11, which we've like derived. And if we test every one out, we can substitute these a's and b's into our definitions for x and y, and then substitute that into m squared, like this definition, to get the value of m itself. For 3 of these numbers, we get stuff that doesn't work. However, this last one is 33, and 33 looks like an integer. So we thus have a equals 6, b equals 5, and m equals 33 works. But remember, we need to find x and y instead of a and b. X is equal to 65, and y equals 56, just by constructing it this way. And thus, we add these up, and we get 154, which is option choice E. Thank you for watching.